Hey everyone, how are you guys? My name is Akash Dev and I am currently doing a 30 days talking to camera challenge. I am doing this challenge just because of two reasons. First one is to improve my communication skills and the second reason is to improve my English speaking skills because my English was very bad before starting the challenge and now I think my English has improved a little bit. Till now I have uploaded almost 24 videos and this is my day 25 of my 30 days of talking to camera challenge, and I am very happy to share that only 5 more days are left. I hope I complete these 5 more days with consistency and I don't take leave at any single day. So now one more thing I wanted to share is before starting this challenge, like when I started this challenge, I had no idea about what to speak about. So I just spoke about my day, whatever I was doing throughout my day and how my day went, how I felt. And later on, after a few days, I realized that sharing these things and talking about these things in camera doesn't make any sense. So then I decided that I should talk about data structures and algorithms because I have been learning data structures and algorithms, and I find this like the concept of data structures and algorithms quite amazing. So that's why I started recording the videos on data structures and algorithms. Till now, in my recording the video series or my 30 days of talking to camera challenge, I have talked on many topics like heap, different types of searching and sorting algorithms, heap sort, merge sort, quick sort, linked list, stacks, queue, different types of linked list and many more topics. And in my yesterday's video, I had told about graphs. What are graphs? Some different types of graphs and basic terminologies regarding to graphs like nodes, paths, vertices, edges, and all those stuff. Now in today's video I will be continuing the graph. This is the continuation of my graph video, and today I will be talking about how graph can be represented and some more topics regarding graph. So let's start the video. How graph can be represented? Graph can be represented using two things. First is adjacency matrix and second is adjacency list. These are the two most common ways of representing a graph. Now here comes a question, what exactly is adjacency matrix? So let me explain. An adjacency matrix is a two-dimensional matrix of size v rows and v columns, where v is the number of vertices in a graph. Adjacency matrix is represented using v into v size 2D array. Let us suppose the array is adj. So the node adj I, j corresponds to the edge from vertex I to vertex j. If adj ij is not 0, then it means that there is a path from vertex I to vertex j. For an unweighted graph, the values in the array are either 0 for no path or 1 for a path exists. But in case of weighted graph, the value in the matrix indicates the cost / weight of a path from vertex I to vertex j. So what I am trying to say here is, suppose let me like explain these things to you a little bit, and let me try to visualize you the concept whatever I was trying to talk here. So so suppose I have given a graph with 3 vertices, vertex A, vertex B and vertex C, and I have an edge from A to B and B to C. Now in my matrix I would have like 3 rows and 3 columns A, B and C and A, B and C, and if there exists an edge from A to A, then I would like write the number at 1, that is ith element is also A and jth is also A. So 1, 1 would be 1, and if no edge exists, then I would write 0. In case of A, I know that there is not a loop. So because if I am telling that the starting point is also a vertex and the end point is also n vertex, so it is only possible if there exists a loop, and since there is not a loop, then I would say it as 0. Now I know that there exists an edge from A to B. So if an edge exists from A to B, then I will write it as 1 in the place of like A and B, like where the row is A and the column is B. Likewise, if there is no edge, then I will simply write 0, and if there is an edge, we will write 1. Now this is the case of unweighted graph. What if we are given with a weighted graph? If we are given with a weighted graph, instead of 1, we would write the weight of any edge between any two vertex. So previously we are writing that if there exists an edge from A to B, then I would simply write 1 where ith row and ith column is, I will simply write there 1. And if there is 5, the weight of the edge from A to B is 5, then I would simply write 5 instead of 1. I hope this was clear. Now let's move forward to our next topic. Before moving on to our next topic, let me give you a little bit of analysis of the code, like how these things is working. So in the constructor of graph of n vertices and n cross n size of 2D array, adj is created. Additional directed edge function is used to add a directed edge from source to destination by setting adjacent source destination field of adjacent array as 1. Add undirected edge function is used to add an undirected edge. It's called and directed edge function twice to join source and destination both ways. I know what I am saying is not understandable to you, but since this is an explanation of the code and code is not available here, that's why I am just reading the explanation from the book. If the code was present here, then I could have explained you these things in a better way. For now, you just like rely on whatever I am speaking, or else if you want more detailed explanation, you could just simply search on Google or see videos of other people also. Many people have explained these topics in very much detail and explain them in very concise manner. So you can go and visit there. My point is not to like explain each and everything as much detail. My main point is to like speak in front of the camera, and that thing I am doing currently. Now let's talk about some the complexity analysis. So what is the space complexity? The space complexity of adjacency matrix representation is big O of n square, because 2D array is created. 1D array takes big O of n space and 2D array takes big O of n square space. It's quite simple. And what's the time complexity? The time complexity of search is big O of 1. To find if there is an edge from vertex u to vertex v can be done in a constant time. Let's talk about some pros and cons of adjacency matrix. So what are some of the basic pros and cons of the adjacency matrix? First, let's talk about pros of adjacency matrix. So pros of adjacency matrix are: queries if there is an edge from vertex u to vertex v, it takes big O of n time. Removing an edge takes big O of 10 time. So if I want to know that if there exists an edge from like a to d, so I can get that in constant time, because I would just check if there is a 1 in like a place of ith row, that is ath row and dth column. Then if there is 1, then I would simply return as true, that is there exists an edge, and if that is 0, then I would simply return as false, that means there is no edge present there. Now removing any edge takes big O of 1 time complexity. Suppose I gave you an ith jth term location in that adjacency list, and I said you to remove that edge. So you would simply put 0 there, and that edge would be removed. So it's taking constant time. I hope this was clear. Now let's talk about some of the cons. So the first cons, as I've already discussed, is the space complexity. It's taking big O of n square space complexity, and n square is a lot of space. Second is, even if the graph is sparse, that is with a few edges, space complexity remains the same. Even if there are few edges, the space complexity would remain same. Why? Because in this case I would have to like allot one extra space for any node, any edge which is not present. So that's why it's taking extra space there. That is, for storing 0 also we need some space. Not only for 1, but for 0 also we need some extra space. Third point is, adding a new vertex takes big O of n square times. Yes, if I want to add a vertex, I would have to traverse through whole array, and the worst case traverse through whole array, and then I could insert a new vertex. So that also takes big O of n square time complexity. Now let me talk about small term, sparse matrix. So what is the sparse matrix? In a huge graph, each node is connected with fewer nodes. So most of the places in the adjacency matrix remain empty. Such matrix is called a sparse matrix. In most of the real world problems, adjacency matrix is not a good choice for store graph data. The problems which I have discussed, that is the cons which I have discussed in the case of adjacency matrix. The one of the cons was like it takes a lot of space complexity. Even the main con was that it takes lots of space, right? Even if the graph has fewer edges, then also it would take a lot of space. So that was the one major con of that. Now let's come to adjacency list. Adjacency list solve this problem. So what is the definition of adjacency list? A more efficient way of storing graph is adjacency list. An adjacency list is an array of linked lists. Each list element corresponds to an edge of graph. Size of the array is equal to the number of vertices in the graph. Let the array be ARR, and an entry ARRK corresponds to kth vertex and is a list of vertices directly connected to kth vertex. The weights of edges can be stored in nodes of linked list. I hope this was clear. Let's move. The adjacency list helps us to represent a sparse graph, and adjacency list representation also allows us to find the vertex that are directly connected to any vertices just by linked list scan. In all our programs, we are going to use the adjacency list to store the graph. So what adjacency list exactly does is, first, like suppose again I am taking that previous example also. Suppose I have 4 nodes A, B, C and D. Now A, B are connected, B, C is connected, A, C is connected and C, D is connected. So here the graph is something like this: straight line, then a triangle, line and then a triangle, A, B, C, D. I hope you are able to visualize these things. Now in case of like adjacency matrix, what I would do is, I would store the value for A, D also. I will allocate an extra space in that matrix for A, D also, and I will write 0 there. But in case of adjacency list, I won't consider that. First I would consider a node, that is suppose I consider a node A first. Then I would allocate which all edges are coming from A. So from A, one edge is coming through B, and one edge is coming through C. So from A I would write B, I would make a linked list, so the head A would be my head of the linked list, and it will then control then store B, and then it will store C. Now I will consider B. What are the edges connected to B? It would connect A, and then it would connect C, since A and C are connected with B. Now let us come to C. Now what edges are connected to C? That is A, B and D, because A, B and D, all the vertices are connected to C through an edge. Now comes for D. For D only C edge is connected, so for D only one node is present. And where the last node will point? Yes, the last node will point to null, as I have already discussed in the English chapter. I hope this was clear, and this makes more sense to use adjacency list than adjacency matrix, since adjacency list is solving my problem of space complexity. I hope all this makes sense. Now let us talk about analysis of the code of this problem. As said earlier, I can't give you a proper explanation of the code, but I will just read the analysis from the books to give you a little bit of idea how these things are working. I know you guys can't understand it if you are like seeing this video for the first time. That's why I recommend you to first see it on Google, or read an article about this on Google, or like watch this from other YouTubers who have explained these things pretty well. I would recommend watching Abdul Bari sir, and there are many more people like MIT. There are video lectures from MIT also, and many Indian YouTubers have also done great job in explaining this concept. So I would recommend you to go and watch those videos and then come to my videos. You can, if you don't want, you should not come to my video, but if you want to give me a like, or if you think that if you want to motivate me, because I don't think I am doing a very great job or something that no one else can do. I am just like recording myself for every day, and many people have already done this. So if you feel like you should like support me, like motivate me, so you can just add a comment or like my video. And yeah, let's talk about the analysis. In the constructor of graph of n vertices, an array of list of size n is created. Add directed edge function is used to add a directed edge from source to destination by adding a tuple to the corresponding vertex list. An undirected edge function is used to add an undirected edge. It's called an add directed edge function twice to join source and destination both ways. Let's talk about the complexity analysis. As discussed in the previous case, the complexity of adjacency matrix was big O of n square, the space complexity of big O of n square, but in this case the space complexity is big O of e plus v to create vertices array to store edge from each vertices. What is the time complexity? The time complexity of searching is equal to the number of edges present in the graph. So in the worst case, it can be big O of e, where e is the number of edges. Now let's talk about our next topic, which is graph traversal. So what is graph traversal? In an array, we traverse the whole array in the straight line. In a linked list also we can do that. In the tree also we can do like in order traversal and pre-order post-order. I have not discussed those. I have not made a video on traversal. I think I would record that video later after I complete the graph chapter. I forgot to record the video on tree traversal. So after I record this video, I will I would like go and record the video on tree traversal also. So please bear with that. And now let's talk about graph traversal. So mainly there are two types of graph traversal method. First is DFS, that is depth first search, and the other is BFS, that is breadth first search. So these are two algorithms to traverse a graph. These same algorithms can also be used to find a node in the graph, find a node is reachable, etc. There are many use cases of these two algorithms, and hence make it very important for us to understand these algorithms. Now, a list of some of the problems that are solved using graph traversal are determining a path from vertex u to from vertex v, or repeat an error if there is no such pair. Second, giving a starting vertex s, finding the minimum number of edges from vertex s to all the other vertices of the graph. Third, testing if a graph G is connected. Fourth, finding a spanning tree in the graph. Fifth, finding if there is some cycle in the graph. I have already discussed what is cycle and what is spanning tree in my previous videos, that is in my yesterday's video where I have given a brief introduction about graph. So I would recommend you to go and watch those videos if you are not able to understand from these problems. Now let's talk about DFS. So what exactly is DFS? DFS stands for depth first traversal. We start the DFS algorithm for starting point and go in depth of graph until we reach a dead end, and then move up to parent node backwards, and this is also called backtracking. In DFS we use a stack to get next vertex to start a search. Alternatively we can use recursion. Recursion is basically system stack to do the same thing. In recursion we call the same function inside the function itself. So we could either use recursion also. DFS of a graph is similar to DFS of a tree. The only difference is that graphs may contain cycles, but trees don't have cycles. So while traversing, we may come back to the same node again. To avoid processing the same node again, we use a Boolean visited array. Now what is DFS? However, I can't visualize you the exact graph and everything, because for explaining you the DFS, I need to like visualize you a very big graph. I can't take a graph of like only 2 to 3 nodes. I need at least 7 to 8 nodes to visualize you how DFS exactly works. So in that case, I would just give you an example. Suppose there is a graph for like something like this, that is coming from top to like down, and there are many nodes present in that. This is the first node and this is the end node. So in DFS, what we will do is we will first traverse through that node and we will come to down. And if I come to a dead end, that is no node is present after that, then I will again come to top, and then I will again come to down. If I again reach the dead end, then I will again come to top, then I will come to dead end, and in this whole graph is traversed. Now let's move on to our second type of traversal, that is BFS. So what exactly is BFS? BFS stands for breadth first search. I forgot to share some more things. So before moving to BFS, let's discuss those things. Stack based implementation of DFS. So what is the algorithm steps for DFS? First, we will put the starting node in the stack, and we will loop until the stack is empty, and we will pop node from the stack called this node current. Process the current node, and either we can print or we can do anything in that we want from that node, and traverse all the child nodes of the current node and push them into stack. We will repeat step 3 to 5 until the stack is empty. Now let's talk about the complexity of analysis of DFS. Time complexity of DFS algorithm, when the graph is represented as adjacency list, is big of V plus C, where V is total number of vertices and E are the total number of edges present in the graph. When the graph is represented as adjacency matrix, the time complexity algorithm is big of V square. We need to traverse adjacency vertex with a vertex which is efficient in the graph when it is represented by adjacency list. Now, what is the recursion based implementation of DFS? The recursion based implementation, that is the algorithm steps for DFS using recursion, is first point. That is first step. In DFS function, we create a visited array to keep the track of visited nodes. Second point, in DFS function, source node is passed as current node to DFS recording recursion function, that is DFS rec or DFS recording, or you can call it anything. What is the third step? In the third step, all the nodes which are visited from index node are further passed to DFS rec function as recursion. This recursion will return DFS function when all the nodes which are visited from source are visited. Finally, we can find if target is visited or not by just looking into the visited array. Let's talk about the complexity analysis of this algorithm, that is DFS using recursion. So the time complexity of DFS algorithm using recursion is same as the DFS done without using the recursion. It is big of V plus C, where V is the number of vertices and E is the number of edges. When the graph is represented as adjacency matrix, the time complexity of algorithms becomes big of V square as discussed earlier. It would remain same only. Now, breadth first traversal. What is breadth first traversal? BFS or BFT, both are same, that is breadth first traversal or breadth first search. This algorithm, a graph is traversed layer by layer fashion. The graph is traversed closer to the starting point. The queue is used to implement BFS. BFS of a graph is similar to BFS of a tree. The only difference is that graphs may contain cycles and trees do not have cycles, as discussed in the case of DFS. So while traversing, we may come back to the same node again. So while processing same node again, we use Boolean visited array. So what is the algorithm steps for BFS? We would this runs in 6 steps basically. So the first step is we would first push the starting node into the queue. Then we would loop until the queue is empty, and then we would remove a node from the queue inside loop and call it current node. Fourth step would be process the current node, that is we can print it or we can do anything from it. And the fifth step is we would traverse all the child nodes of the current node and push them into the queue. And the sixth step is repeat steps 3 to 5 until the queue is empty. So this is the like basically this is how BFS work. Let me visualize you BFS also. So in DFS, what we are doing is we are first coming down, and when we reach a dead end, then we again go up, then come down, then we reach dead end, then again go up, then come down, then again reach dead end, then go down, and likewise when the whole graph is traversed, we would return the answer, that is we would return the traversed array. But in case of BFS, what we are trying to do is first we would go to the first node, and then we would like breadth-wise see the second node, then breadth-wise see the third node, then breadth-wise see the fourth node, and likewise we would like breadth-wise see all the nodes, and when all the nodes are visited, we would simply return our answer. Now, what's the complexity of analysis of BFS? Since there is no such difference between BFS and DFS, the only difference between BFS and DFS is BFS is using a queue and the DFS is using a stack to return the answer. So that's why the time complexity of both is big of V plus C, where V is the number of edges reachable from source node and E is the number of edges. I would recommend you to like memorize the time complexity, because sometimes it is directly asked in the interview and in many examinations. like GATE and many examination, or either in your college university level examination. So I would just recommend you to learn all these values by heart. Let's move forward. So this is our last concept for today. And after that I would end the video, and tomorrow most probably I would record a video on the problems based on DFS and BFS. If I think that I could make you visualize those problems, and if I think I couldn't make you visualize those problems, then I would not record a video on that. I would record a video in travel and in-order traversal, pre-order traversal, that is the traversal method done in the case of trees. And and the same applies to there also. If I think I am able to visualize those things, then I would record a video, or otherwise else I would record a video on some different topics, or like I could record a video on any topic, whichever topic I find suitable. Let's talk about the uses of BFS and DFS. The following problems are solved using DFS and BFS. First one, find if path exists between two vertices can be done using BFS or DFS. Second one, given a starting vertex U, finding the minimum number of edges from vertex S to all the other vertices of the graph is done using BFS. Third one, testing of a graph G is connected can be done using BFS or DFS. Fourth one, finding if there is a cycle in the graph or check if given graph is a tree is done using DFS. Fifth one, topological sorting is done using DFS. Sixth one, strongly connected components of a graph in directed graph is done using DFS. So I hope all the uses of DFS and BFS is clear. Now comes the problems using DFS and BFS and the problems of graph. So if I think I could visualize the problem, I would record the video, and if I think that I can't visualize the problem, then I would simply record a video on any other topic. It could be any topic. So let's keep up to this only. And if you think that if you get a little bit of inspiration from what I am doing, and you also like start your own YouTube channel or start recording videos, although I am not very great, or like I have 1 or 2 subscribers and no one literally watches my videos, still I think that I feel like I have to say all these stuff. So that's why I am saying, please don't judge me on whatever I am doing. If you don't like my content, or don't give a thumbs up, or like add a good comment, please don't write a bad comment also. And if you have watched the video this far, then I think you are genuinely like my content. So I would recommend you to see my current video, that is see this video, and see my first video or my second video on my channel. And please do like tell me a comparison about what is there anything I have improved, or is there something which I should improve for my upcoming videos, or is there anything that is stopping me from enhancing my skills, or like giving my best, giving my 100%. So I would highly appreciate if you write those things in my comment section. I definitely want someone to like appreciate, not exactly appreciate me, but tell me my faults of where am I lagging, so that I can improve itself also. But please don't give hate comment. Even if someone is giving hate comment, I don't really care, because I am doing all this stuff for myself. But if you guys really put a positive comment, then I really love it and appreciate it. So yeah, that's all for today. Thank you so much guys for watching the video this far. Thank you so much everyone. Bye bye, all the best.